Okay, so we've got two capacitors, one of 6 microfarads, and one that's 18. That are first completely discharged, and then connected in series. So the series combination is connected across a 12-volt battery. So we've got 6 microfarads, 18 microfarads. Okay. Next, they're carefully disconnected, so they're not discharged, and then reconnected to each other in parallel. So we've got, so it goes to here. And it wants us to find the potential difference after they are reconnected and find the energy stored before and after reconnection. Okay, so first off, we need to find the charge carried by these capacitors, and to do this, we need the equivalent capacitance. So 1 over C12 is 1 over C1 plus 1 over C2. So 1 over 6 microfarads plus 1 over 18. So our C12 comes out to be 4.5. Now our capacitance is the charge carried over the voltage. So our charge is capacitance times voltage, so 4.5 times 10 to the minus 6 farads times our voltage, which is 12 volts. So our charge comes out to be 5.4 times 10 to the minus 5 coulombs. And so this will be the charge carried by each device as they're in series. So 5.4 will be transferred here, and then will be transferred there. Now they're disconnected. Again, each will carry 5.4 times 10 to the minus 5 coulombs. So our total charge is 5.4 times 10 to the minus 5 coulombs plus 5.4 times 10 to the minus 5, which is 10.8 times 10 to the minus 5 coulombs. Now when they're reconnected, they will distribute their charges, but our Q total will still be 10.8 times 10 to the minus 5 coulombs, but that will equal our new charges on each capacitor. They will redistribute to maintain the same voltage, so V1 will equal V2, and we'll still have that our capacitance is equal to our charge over our voltage. So then, or rearranging this, our V1 is Q over C1. And I'll write it as Q1 prime. And V2 is Q2 prime over C2. And so then using this, our Q1 prime over our C1 is equal to our Q2 prime over our C2. And then using that our total is Q1 prime plus Q2 prime, then we can say that Q1 prime over C1. So Q2 prime is Q total minus Q1 prime. So Q total minus Q1 prime over C2. And now we can rearrange and say that our Q1 prime onto 1 plus, nope, yeah, 1 plus C2 over C1 is equal to our Q total, or our Q1 prime is equal to our Q total over our 1 plus C2 over C1. Did I do that right? Yeah, I think so, yeah, okay. Which is equal to our Q total times just giving common denominator here and flipping, which is our 10.8 times 10 to the minus 5 coulombs times our C1, which is 6 microfarads over 6 microfarads plus 18 microfarads. And so our Q1 prime comes out to be 2.7 times 10 to the minus 5 coulombs. And then our Q2 prime can be just figured out from the difference. Which is 8.1 times 10 to the minus 5 coulombs. And then now we can verify by saying that our voltage should be 2.7 times 10 to the minus 5 coulombs over 6 times 10 to the minus 6 farads. And it should equal our 8.1 times 10 to the minus 5 coulombs over our 18 times 10 to the minus 6 farads. And we can verify that indeed we get 4.5 volts in both cases. So that's as asserted. We asserted that the voltages should be the same, and they come out to be the same, so we didn't make any mistakes. So there's our potential differences across each capacitor. So now our energy stored is 1/2 times the capacitance times the voltage squared. So before they're disconnected, we have our equivalent capacitance. So our C12 is 4.5 microfarads. So our energy was 1/2 4.5 microfarads. Our voltage was 12 volts squared. If we do this out, it comes to 3.24 times 10 to the minus 14, times 10 to the minus 4 joules. And then after we reconnect them, we now have two separate capacitors in parallel, so it would just be C total is C1 plus C2, which is 24 microfarads. And so our energy is 1/2 times 24 microfarads times the voltage we solved for, which was 4.5 volts squared, which comes out to be 2.43 times 10 to the minus 4 joules. Okay, so checking our solutions here. So up to the top here, so I don't know what was circled there. So our equivalent capacitance is 4.5 microfarads. So we got our total charge as 5 0.4 times 10 to the minus 5 coulombs, or 54 microcoulombs. Our total charge is then 10.8 microcoulombs, or 10.8 times 10 to the minus 5 coulombs. So continuing down here, so we get that our voltage difference is 4.5 volts, so that's good. Our energy stored before is 324 microjoules, or 3.24 times 10 to the minus 4. And then afterwards is 243, or 2.43 times 10 to the minus 4. So that looks good.